Hey, all. We're going to get started in a moment, but do we have a note taker? Is anyone willing to volunteer to be a note taker? Oh, great. Thank you.
I think Chris would volunteer to me earlier for whatever parts he's not speaking for. But a second set of hands would be good.
I think Eric, right? Oh, perfect. Thanks. Right, Richard, good to get started. Perfect.
Yep, whenever you're ready.
Yeah,
Yeah. If you think that we have the people we need in the room, what's going on?
your audio is a little bit um, unclear to me, but maybe that's just me. But okay, cool. Right. Welcome all to Ohai. I am one of your chairs, Siobhan, and we have Richard joining in remotely. And yeah, I think this is the note well. Please note it well. Also, um, the IETF has a masking policy, which means that if you're in this room, you should be masked. So just keep that in mind. And just a reminder that we are using Meet Echo, and we will be having like a virtual show of hands at some point in this meeting. So you will need to use the on-site tool if you're in the room. And then in Meet Echo, I think if you're online, then you should just be able to, you'll get a pop-up um, over there. So yeah, just keep that in mind that you might be asked to use the on-site tool. Um, Perfect. And we have a note taker. Thank you, Eric. So I think we can get started. Chris or Martin, who is doing the presentation? Chris, okay, perfect.
What's that?
Yeah.
All right. Okay. This is just hopefully the last update for the main document that we're working on this particular group, OHTTP. Next slide, please. There are a number of updates based on the last version of last couple of versions of the draft between last IETF and today. I think the biggest one is this state-based anti-replay mitigation that we discussed in IETF 113. Basically, the idea being that if a client sends an encapsulated request to a gateway that can't process it because it was like too old in the past or the clocks are too different, the gateway would just respond with like, here's a new a date to retry your request with, such that I can apply like anti-replay in a meaningful way without keeping endless state on my side. We went through the use case last time, went through the proposed mitigation, or the proposed mechanism, and the text was landed in the draft. However, as I'll discuss in a little bit, we've now yanked some of the contents of this particular mechanism that were previously outsourced to another draft that Martin wrote back into the main spec here. And there's a pull request up for actually landing that particular integration. And that's one of the like remaining things to be done, but it's basically just moving bits around between two documents. Anyways, beyond that actual mechanical change in the draft, there's a number of like actual terminology and editorial things that we fixed. As people probably saw, we had this tremendously successful bike shed on the mailing list where we like moved away from proxy to relay and target to gateway, hopefully to make the different roles of the parties in the system more clear and what they're doing. And we did our best to make sure that the contents of the draft actually match what was discussed in the mailing list. But there may be some like residual references to proxy or whatever. So if there are, please be sure to let us know. Improved text on various like privacy related things, in particular, like what can happen if a relay happens to be uh, offering different services to different clients in response to like how a client is interacting with a gateway, or how a client is interacting with a relay, and what that differential treatment has on the privacy posture of the client interacting with the gateway. The primary motivating example for this particular body of text was the shadow banning use case, where a relay might want to signal to the gateway, hey, this particular client is, has been flagged by some mechanism, and the relay or the gateway might then choose to uh, act differently based on this particular bit, and how that impacts the overall privacy posture of the client is worthy of consideration. So now there's text that actually talks about this. The big like breaking change in the latest version of the draft, thanks to David Benjamin, is a change to the key schedule. A very minor change, but it is a breaking change nonetheless. And I'm just going to quickly summarize what happened in the next couple of slides. So next slide, please. Okay, so the old key schedule looks something like this. I've simplified things a lot just to kind of show where different inputs to the key schedule go. Some of the inputs, like for example, on the left side with the client, you have like the gateway's public key. You have the context string for HPKE that's fed into like create an HPKE context for actually encrypting or encapsulating things to the gateway. At the bottom, we have what I refer to as the OHTTP configuration parameters. That includes like what HPKey, cipher suite, chem, KDF, AAD, and whatnot was configured, what the key ID was for that particular encryption, and those are bound to the actual encrypted request that goes out. Note, importantly, that these configuration parameters are not bound to the key that's exported from this HPKE context, which is relevant. If you go to the next slide, please. Because this exported key is the thing that's piped in and used by the gateway for actually encrypting the response back to the client. So we had the situation where the ciphertext was not entirely bound to like basically everything the client had when it started its encapsulated request. It was only bound to public key and the content or the context string, which is OHTTP / request. And the fix was simply to, next slide, to lift everything that was previously piped into the AAD and just like plumb it into the HPKey info, into the HPKey key schedule, so that it gets folded into the export key, such that the request that gets encrypted from the client, as well as the corresponding key or content that's encrypted from the gateway back to the client using the exported key, is all bound to basically everything. And there's not, like at the bottom, I've written that there's nothing that's sent to the AAD as additional authenticated data, because everything is now piped in through the HPKey info parameter and therefore bound to the key schedule. So there's not any more possible binding that we can do. I think this is like this is complete. Okay, and then as I was referring to earlier, we had this other big kind of mechanical change that was landed in the last version of the draft between, or since the last meeting. We were previously referencing this draft that Martin wrote, but kind of in a unknown installed state in HTTP right now. So we figured rather than just block on that indefinitely, let's just yank the stuff out of that draft that we need for OHTTP specifically, and then make forward progress. So there's a PR up, PR 137, that basically does exactly that. It takes the pieces that are relevant for OHTTP, adds them to the document, and describes basically how clients should respond if it receives a date or a response that's not successful with a date header in it. And it talks about how a gateway should use that header, use that date header for the purposes of triggering this retry functionality from the client. And there's lots of privacy considerations there about like clients should not just indefinitely retry with, new dates and whatnot, and it should not use a date from a response that it gets from a gateway for more than one request, and so on. So relatively straightforward, and this is purely editorial, just lifting text from one document to another. Next slide, please. Okay, at this point, I think barring merging this particular editorial change, the document's feature complete. We have a number of interoperable limitations at this point. It's a simple protocol, and I think at this, we're kind of ready for a working group last call unless there are any other things that people would like to add. So I'll turn it to the chairs now to see what they want to do.
Yeah, I mean, if folks have comments on that, please line up. I guess on both the issues and on the particular issues that Chris talked about, but yeah, maybe we can start with that. Does that sound okay to folks? Okay, do folks have comments about last call? We'll also do a show of hands, but if there are any serious concerns, then right now would be great to hear them.
Does anyone know any reason why we should not send this document off in the working group last call? Speak now or hold your peace until last call.
Okay. Maybe a good question to ask is, have folks read the draft? I'm going to start a show of hands online. If you're on site, you will have to join the on-site tool.
I skimmed it.
So we have folks chiming in right now. About an even split so far.
I've got, nearly a dozen people who've read it. Seems pretty reasonable.
Okay, we have about 68 people in the room, so it'd be great if folks can say whether or not they've read the draft. Okay, just giving it a few more seconds. Okay, I'm going to close it now. There's about, I guess, out of the 40 people who said, the people who participated in the poll, 15 people said that they have, and 26 people did not raise their hands. So then, okay, let me just end this and then ask my second question. Which is, do you think the draft is ready for last call? You want me to vote for you? Sorry? You want me to vote for you? Yeah, and the folks who said no, it'd be great to hear why, or if folks don't have, if the people who are saying, like, who voted for no, like, I can also assume that means that you don't have an opinion, which is fine. But it would be great to hear any concrete reasons as to why not. Okay, I think we can close the session. Like overwhelmingly, people who participated in the poll said yes, so we'll confirm on the list as well, but this looks pretty great. Great, is there anything else you guys want to talk about?
No, we'll merge the PRs that are open. We'll add some editorial text for your issue, and then I think we can move forward. We'll cut a new version soon.
Sounds great. Thanks, Chris. think. Yeah, Tommy, did you want to talk about the SVCD?
Okay, hello everyone. I'm Tommy Pauly from Apple, and we have a document we talked about last time, I think. Tiru also was helping on this, and essentially now that we have our basic OHTTP definition, this is getting a little bit more into some of the use cases and deployment models. The kind of default that OHTTP has expects that you have very coordinated deployments where the clients and the targets and the gateways and the relays kind of all know that they're working together, and that is all out of band. That works fine. That is certainly one way to use it. But there are also potentially some use cases for doing a bit more dynamic discovery. And so that's what this document tries to talk about. Next slide, please. So I'll talk about two different use cases here of like the general model for how you would imagine this particular form of discovery being performed. So we start out in this world with a client that knows it wants to use a particular target service, is talking to it already, or it knows it's about to talk to it. And the client also knows that it has some trusted relay service that it prefers to work with, or it knows has access to somewhat generic OHTTP gateways. Next slide. And if in this scenario, the client can learn that the target service has an associated oblivious gateway that this target service prefers to use to provide access to it, then next slide. The goal is, is there a way to essentially upgrade this path if the client wants to go through its oblivious relay through that oblivious gateway to get to that target service as an alternate way to reach that target service as opposed to going direct. Next slide. The second use case is one in which you are using this target service through the oblivious gateway as an option that you otherwise would not use. So the model that we have here is something that we practically have when we're doing DNS over oblivious HTTP. And in this model, let's say the client has its trusted relay again, and it has a default oblivious gateway and a default DNS resolver that's going to use. In general, it already has this provisioned out of band. But then it is interested to say that if under a certain scenario, like it's on a network that has a resolver configuration that it would prefer to use because it provides the right either filtering for the requirements of being on that network or resolution for access to internal domains that are particular to that network. If the client can discover that there exists this DNS server that has a oblivious gateway, it could use that in addition to its default service or in place of its default service. And this works well with some of the ADD work around discovering designated resolvers. So those are kind of the two models that this document can serve through a single mechanism. Next slide. So the scope of this document, it's pretty short. We've gotten good feedback, and I think the current shape is something that kind of is a bit more of a complete story and can actually work viably. There are two parts to it. One is essentially a way to learn that a service has an associated gateway, which is kind of one piece of the puzzle. And I would like to thank the main OHTTP authors for clarifying terminology around gateways and targets, because that makes it actually much easier to refer to things and be clear about what we mean. So essentially you have the full URI of the gateway, and that can be stuffed in a DNS record in SVCB parameters. And then the other thing you need to do as a client is know what is the key configuration, and the current way that is done is just saying, hey, if you have this gateway that you would normally do a oblivious request through a post to, let's just do a get and specify that I want to get the key configuration from it, and that is a way to fetch that. These are just essentially the proposed mechanisms. I think for any discovery mechanism like this that's trying to achieve those goals, these are the two pieces of information you need. So we can, of course, debate what is our preferred way of getting these pieces of information. Next slide, please. So just concretely, to give examples of each of these, we have the DNS response, which can include the oblivious gateway, and it's just encoded there as a URL. And for the key configuration query, we just do a get, and we say, I want to get the OHTTP keys. So it's pretty straightforward from that perspective. Next slide. I think the interesting part here is how you protect against key targeting or URL targeting, and making sure that a user that's learning about this isn't being singled out. If you do have a unique gateway URI or a unique key config, then the client can be targeted or identified when it's using the service. You could have your proxy or relay try to participate in recognizing, like, oh yeah, this is a common gateway versus, that's a gateway that only you are using. But there are different ways of doing this. I think this is where a lot of the interesting discussion lies. And I know that there are multiple other conversations in this working group and others talking about consistency and key targeting and ways to mitigate that. So I think this can fold into that broader conversation as something that would like to benefit from those. Next slide. So that's it. I think at this point, it's mainly a question of, is the working group interested in taking on the discovery of a gateway and its config problem? I think it's in scope for what is in the working group's charter. We're kind of done with the main protocol, so it seems like if we want to do this at some point, then this is a decent time to do it. Love to hear feedback.
Ben Schwartz, oh, I forgot to use the queue. Martin's actually in the queue. I'm having trouble understanding the security properties here. It looks to me like this still suffers from some of the same problems that I was concerned about with the first revision of this draft, which is that an intermediary on the DNS path that can modify this record could swap out the gateway entirely for their own gateway. And as far as I can tell, there's nothing here that would detect this on the client side. So I could take any origin in the world, even an origin that doesn't have any support for oblivious HTTP, and if I can intercept the DNS, then I can inject myself as the gateway, claim that OHTTP is supported, and then impersonate that origin, essentially bypassing the protections of TLS.
So I think in this case, that mainly comes down to how do we do some sort of consistency check on the side, which I think it's important, and I think that's something that we should talk about.
So thinking about consistency for a moment, it depends what you mean, maybe. If consistency is about making sure that a given gateway shows the same key configs to everybody, then it's definitely not sufficient here, because I can mint, first of all, I don't need to, I can give a single, the attacker can have a consistent gateway and still be consistently impersonating the origin.
Well, and I think one thing important parameter to keep in mind here is that Ohai provides no, if you're accessing a target over oblivious HTTP, there is no confidentiality or integrity protection against the gateway.
That's right, and that's why the gateway always has to be provisioned through a trusted channel. And in this case, I see the gateway being provisioned through an untrusted channel, at least in the threat models that I'm used to.
Okay.
So on the adoption question, I do want something along these lines. I do think that I'd like to see the working group work on discovery, but I think maybe we need to have a little bit more consensus about what direction we're going to go before we proceed with an adoption.
Sure, and I'm happy to have the working group work on that too. I'm more interested in saying that the working group should be working on the problem. That's a good point.
Yeah, so I think this is an important point, and I've just made some changes, I think, to the base specification that sort of address this point. If you have the gateway operating on the same server as the target, then I think the concerns that you have are lesser
Yes.
than previously. And I think that's what Tommy wants to do.
Yes. But so that is an interesting point, that if they are not co-located, how do you establish that they're actually related? But if they are, like if you use the same TLS handshake to get to them no matter what.
Right.
Like
Then-
if the thing I'm fetching my key config from with a GET request is the thing that is my target service, does that provide enough binding to trust it?
Yeah, but
No.
Ben's right. He shook his head. There are those scenarios where you have multiple tenants on the same host, and
Sure.
some of them have control over some resources,
Sure.
but not others. And if they're in a position to put themselves in the position of the gateway, they are then able to do that. Which
Yes,
is why I
okay.
think the use of .well known in this context does give us something.
Okay.
And
I moved
so-
off of well-known because you said you didn't like it. so
I know.
I'm
I don't-
happy
I
to move
hate
back.
.well known,
Yes.
but I've realized that I think perhaps in this case we probably need something along those lines
That's
because of this reasoning.
That's fine.
And that's only a recent realization on my part. And I think
Yep.
thanks to Ben and
Yep.
Richard and others for pointing out some of these flaws, I think that's probably where we're going to need to go
Yep.
with this one, unfortunately.
That
Which
makes sense.
Might be better because we have fewer parameters in our
Yes.
service params, which is also
Yes, it
positive.
does simplify that. Yeah.
Eric Gorth, Google. I agree mostly with what Ben and others are saying about all the correctness and consistency concerns. It is an area we definitely need to solve. There's huge concerns there.
Sure.
But I think that's a big enough area to solve that should be a separate draft. And I think Ben's presenting something like that in 15, 20 minutes from now, so we can discuss that a little bit more there. But assuming we have stuff like that solved in a separate draft saying, here's how to get these packets of information securely and consistently, I think there's good room for this draft to focus much more on just the payload itself. Say, here's how you give the discovery info and the key info in DNS. Here's how you give it in an HTTP request.
Yep.
And then point to the other stuff and say, these are the ones that tell you how to fetch that securely and safely and all that stuff. And those ones can point at this one, say, here's the format of that. So I'm very supportive of working on stuff like this and adopting this as long as we focus on that. And probably in a separate draft, we have to handle all the consistency and corrective stuff because that's hugely important and probably important enough to be separate draft from this one.
Yep, makes sense.
I think that the group does need to work on discovery. I think it's really important. I think, though, it'd be helpful to try and ensure that there's a separate discovery for the gateway and the relay to minimize the risk of collusion between those two. If they're discovered using the same mechanism, I think that is risky.
Right, and this mechanism is explicitly only about the gateway associated with a service, which, to Martin's comment earlier, probably needs to be entirely co-located in order for this to work. Like essentially, to recognize that the target has a gateway. The document says like, yeah, the relay discovery is out of scope, and I think if people are interested in relay discovery, which is fine, that is something that needs its own considerations and likely would be related to discovering more general purpose relays, because an OHTTP relay likely would be able to serve as a much broader category of relay for things like mask or just being able to do other DNS services.
So for the avoidance of doubt, I think both should be addressed. So it'd be good if both were in scope.
Yeah. I do have a little bit of a question on the relay discovery question. If depending on what that mechanism ends up being, that may not belong strictly in Ohai. If it is something that is potentially more generic, whereas the Ohai gateway configuration really is truly specific to Ohai and doesn't apply to anything else. So that's why I believe it does belong clearly here, and I'm just not sure about relays.
Do folks have opinions on whether this, like as the document stands right now, like this is the right direction to go in, like gateway discovery driven by target?
Yeah, Chris would. I do think so. I mean, sure, there might be some key consistency things we have to sort out, but this draft is a good step in the right direction, and I think it should be adopted. I do not think we should pull in things like relay discovery. I think that's a separable and much harder problem, as you have indicated. So,
And I'm happy to like switch things to well-known and address the security thing before we talk about adopting it too. Like that's just a trivial revert.
they also seem like perfectly reasonable things to bash out in the working group. Like,
That too.
I think the problem is clearly stated in this document, and I think we all understand it, and we think it's useful to solve. But that's my impression.
Does that help, Tommy? So do you think maybe like a revision first and then?
Yeah, I can revise that like next week, and then we can talk about it further. Thank
That
you.
sounds great. Thanks. Great. I think we have Dan next.
Yeah, can you share my slides, or should I do
Yeah,
that?
1 second.
Yeah.
Yeah.
Cool.
I can hand over control, right? Okay, you should have control now, Dan.
Okay. So I'm presenting on behalf of my co-authors. Turo just started working for Nokia this week, but because the draft is still showing him as the affiliated with Akamai, we're leaving it there. So we made some changes to update the document based on some feedback and to align it with the HTTP API rate limit headers we'll talk about in some detail. So to recap, what this draft is doing is trying to help identify misbehaving clients that are abusing the target and allowing the proxy to know about those and slow those down, because the alternative is bad. The alternative is slowing everything down. So the change to use the HTTP API rate limit headers is we're extending those slightly to include detail that is just for the proxy, so that the proxy knows that it's supposed to process that header and deal with it and not pass that on to the client, because it's not useful for the client. So the underscored and highlighted text here is the extensions that we're describing in the draft now. The HTTP target equals 2, I talk about in a couple of slides from now. And that is a signal to the proxy that this is a certain style of it, of an attack, and a certain style of behavior that we would like to see from that proxy. And if the proxy can't meet that, there's no feedback that it can't or it won't. It's just a way to hopefully prevent all the traffic from that proxy from being throttled by the target because of a single misbehaving client, such as one sending malformed HTTP or some other sort of attack traffic that is either purposefully malicious or accidentally malicious because something has gone wrong in the client. And this is the example message flow. It's very much like the HTTP API that we're patterning this after, but we're just tacking on the HTTP target parameter to this that is processed by the relay that's proxying the traffic. And the interesting one here, one is somewhat interesting. Number two is where it's more interesting in that the client traffic is identified by the target as being somehow malicious. Malformed HTTP is the easiest one to conceptualize. And the other change that we made that is probably interesting to the working group is the proxy doesn't need to take account immediately, but can wait until it receives several of these messages from the target complaining about the same client, and then start taking action against that client to rate limit what it's doing. The purpose of that is to prevent the partitioning of good clients from bad clients, or rather, prevent the partitioning of good clients and good clients, such that we're only partitioning the good clients versus the bad clients, where the bad clients are generating bad HTTP and bad transactions. And one other addition to the draft is a mechanism for the proxy and the target to communicate with each other about which headers that they're going to understand between each other. The value here is if they're not configured by the same entity, where the changes can be pushed out at the same time, then this helps prevent inconsistencies in the configuration between the proxy and the target, so that they understand the headers that will be stripped by the proxy and the headers that will be sent by the target. And that's this draft. Are there any questions?
Ben Schwartz. So yeah, I think this is similar to my previous concerns here. The OHTTP target equals 2 setting appears to allow an instruction from the gateway to the relay, telling it to apply special treatment to a particular user. It seems difficult to me to understand how you do this within the OHTTP threat model. Basically, the gateway, if it wants to try to link different requests, if it sees a bunch of requests coming in and it wants to slow them down, that in a sense, by definition, is linking them, right? If you believe that this particular flood of requests all comes from a single user, being able to answer that question in any way breaks OHTTP's unlinkability guarantees. So, so I'm not saying it's technically impossible. I'm saying that we need to be very careful about what we recommend here, because we're punching a hole in our own privacy claims.
Right. Okay.
And so I think there's a really interesting question here about what a relay can safely do, or how much damage it does when a relay starts to comply with these kinds of requests. And I would certainly, before the draft was adopted, I would want to see some very sharp analysis about what damage that is.
Okay, that's fair. Thanks.
Yeah, I think I have similar concerns to Ben here. I think that there has been some changes in the base document where we talk about the sorts of things that a client might need to be aware of in terms of the way that the proxy, or now the relay, might apply differential treatment based on characteristics of the client. So for example, if you wanted to implement a shadow banning type arrangement and the relay was aware of a flood of messages coming from a particular client, it might include a 1 bit of information toward the gateway or the target that would allow the gateway and target to differentiate behavior with respect to those particular requests. So that's one type of treatment that we've considered. But in doing that, we've tried to be very, very clear that the client needs to understand the scope of the things that are possible in that context. Once you add feedback into the loop, it becomes much more complicated in terms of giving the client some confidence that the gateways and the targets aren't trying to back out the privacy protections afforded by the relay. And so I see a lot of positive movement here. I think that the sorts of things that you're doing in terms of trying to disconnect the immediate effect of the feedback from the actions that occur is probably a good direction to have. I'm afraid I haven't read the very latest in this, but I would like to be more confident that that analysis was good before I would be confident moving forward. I think there's probably a few things we could change about the spelling as well, but that's separate.
Okay. Thanks, Mark.
Does that sound good, Dan? Sounds like the consensus is not yet, and we can revisit this in a bit.
Okay, sounds good. Thank you.
Great, thanks. Ben?
Hi, Ben Schwartz. Is there a clicker? Is there a magic clicker? No? Okay. The agenda said I had 5 minutes, so I squished these slides down to nothing to try to squeeze it all in. It seems like maybe we have a little more time than that.
Yes.
So maybe I'll try to explain a little more what's going on. So this is a presentation of the first presentation of a new draft from just me for Ohai. And this is about trying to solve what I think of as the gateway key consistency problem for oblivious HTTP. Although it might have some more general applications, but let's move to the next slide. So I think it's easiest to think about this in concrete terms. So let's pick an arbitrary concrete example and talk about this sort of telemetry use case that's mentioned in the OHTTP document. So imagine that your OS default installation state reports telemetry to some sort of remote service, and that remote service supports OHTTP. Now, you believe that the OS image, or I believe that my OS image is the same as everyone else's. I haven't been served a custom crafted OS image that points me to a unique instance of the telemetry service. So I believe that that there's essentially that is already consistent. But I still don't trust the telemetry service not to try to link my reports together. If I trusted it, then I wouldn't need OHTTP. So I've configured my OS to make use of that OHTTP service. I'm using an OHTTP relay, and I trust that relay not to collude with the telemetry service. But in this case, also, I don't fully trust the relay. I don't trust it to see the plain text context of my reports. Otherwise, again, we wouldn't need OHTTP. So this is trying to get to the point where we actually need OHTTP at all. OHTTP serves a pretty narrow use case. Okay, so with all those assumptions, how do I convince myself that I'm using the gateway URL, key config, and target URL? So in this case, the target URL is the telemetry service. How do I convince myself that those are authentic? I'm actually talking to the telemetry service, not some random attacker, and that they're the same ones that everyone else is using. Because if any of those are unique, if the gateway URL is unique, if the key config is unique, or if the target URL is unique, then I am uniquely, I'm linkable, and so I've lost my OHTTP protections. That's the problem. How do we actually get the OHTTP protections? Next slide. Okay, there's an easy answer to this. You just hard code all of these right into the OS image. We've already assumed that the OS image is globally consistent, and I haven't been served a unique OS image that was custom crafted as an attack on me. So that is the easy answer, and it does work. And we can generalize this and say, you know, any OHTTP system assumes some kind of trusted bootstrap stage that is providing consistent information to the world. I could just get all of this through whatever my bootstrap stage is. That's fine. but I don't think it's very attractive as an operational practice. Among other things, it prevents key rotation. If you bake the key configs into the operating system, you can't rotate the keys. So that's a pretty obvious problem. And there are other changes you might like to make. Maybe your gateway is operated as a hosted cloud service and you want to change service providers to a different gateway operator. Next slide. So this proposal tries to solve that. It tries to enable, in a sense, dynamic bootstrap without losing the OHTTP privacy guarantees. And this is how it works. First, you create some kind of config file that holds the gateway URL, the key config, and a description of the actual service you're trying to reach, target URL. I have been calling this the service description host. That's the origin that hosts this thing. This is all, there's another draft that I'll be talking about in Mask that actually lays out a format for this kind of config file, but the exact format doesn't really matter here. So we fetch this config through the relay, and we ask the relay to act as a cache. And this is basically just an HTTP cache. This is like an old-fashioned HTTP forward proxy before HTTPS. So it's like a caching forward proxy. We just ask the relay to fetch the service description for us. And since it's in cache, it's usually in cache, we get back the same answer as all the other users of that relay. Crucially, one of the crucial observations here is that the consistency problems for OHTTP are only scoped to each relay. It doesn't matter whether users of different relays have consistent views here. So like we've talked, one of the things that comes up occasionally, and Chris Wood has enumerated in a draft all of the sort of basic strategies for dealing with the key consistency problem. Some of them look like blockchains, and you know, that's a very powerful global consistency mechanism, but it actually doesn't really matter because it doesn't matter beyond the scope of a single relay. If you're using a different relay, you're clearly a different user. So, to get consistency scoped to a given relay, we just essentially read the description out of a cache held in that relay, and so all the users get the same copy. And that gives us consistency. But it doesn't give us authenticity. Again, we don't trust the relay not to try to impersonate the gateway. So the relay could just be lying to us, giving us its own key config. So to solve that, we fetch it again. And this time, we fetch it directly from the service description host over a standard authenticated HTTPS. And now that gives us authenticity, but it doesn't guarantee consistency. So to make sure that we have both, we just check that they're identical, and they should be identical. There's a little detail here that we ask the relay in this system to also be a mask proxy, so connect UDP proxy. That seems, as Tommy suggested earlier, that seems like something that may be pretty common. And that's not strictly necessary, actually, for our consistency guarantees. But if you don't do that, then the gateway ends up with a list of all of the IP addresses of the users behind the relay. And while it can't then link requests to one or the other, you can imagine that it might, for example, take those IP addresses to a data broker who tells it more information about the users that it could eventually use to profile them and identify, you know, this request is really only likely to have been from this particular person who I now know quite a bit about via their IP address.
And
Okay,
quick clarifying question here. You're assuming the relay and the service description hosts are not colluding, correct?
I'm sorry, I didn't quite understand the audio.
Sorry, I was asking if you were assuming that the relay and the service description host are not colluding with each other. Because it seems like if they are, then the relay could lie about the cache, the data in the same way the service description host does.
I think that's right. The service description host is with the gateway and target in the sort of OHTTP partitioning of roles. So the service description host is assumed to be an agent of or closely affiliated with the gateway and target.
Okay, thanks.
Oh, okay, next slide. Okay, there are a lot of details in the draft about exactly how this works. It's all in the draft, in this proposal, it's all stitched together from standard HTTP stuff, lots of different headers for standard caching headers. There are a few slight tweaks beyond what is just required by the standard implementation of these headers, and that gives us defenses against a bunch of different kinds of attackers. So we consider both in malicious relays and malicious service description host / gateway / target. As I was discussing earlier, the draft also tries to acknowledge the possibility of malicious clients who are colluding with the service description host to, for example, try to overflow the cache of the relay in order to reset its state in order to serve different service descriptions to every user for linkability. And the draft also talks about the performance considerations. You might think that fetching this service description twice before you can use it is a big performance penalty. I actually think it's pretty manageable. In my analysis in the draft, I think it adds up to about 2 round trips, basically the same as a fresh, quick setup. One round trip to set up quick, 1 round trip to fetch the fetch the resource. But I think that for most of the use cases we're talking about, once you get that service description, it's good for hours to days. So 2 round trips once a day or something like that, I think is pretty manageable. Okay, last slide. So my current thought is that this could be a good document to fit into Ohai. And I think it will probably evolve quite a bit, but I would like to see it move forward here to try to unlock some of those broader use cases where you're discovering your gateway as you move about the internet.
Cool. Martin, I think you were first. No. Okay.
Hi, Ben. Thank you for sharing this. I originally was going to come up with just kind of about a nit for where you're listing like, oh, the other check would be connect UDP. That works if your target server is doing quick. It obviously could just be another H2 server. So like, connect UDP, some variant of that. And I think really rather than talking about that, it would be useful to structure this in terms of the TLS context in which you are fetching the key config, right? So like you want one TLS like a TLS connection to the actual service description that's like authoritative for this target, and then another one to a different context, which in this case is the one on the relay. So like you have essentially 2 TLS handshakes to 2 different entities, and they both agree. And then really at that point, I imagine like that other one doesn't even need to be the relay that's caching. It could just be anyone else. So I think this sounds like it generalizes to check with the person who says they own the key config and check with someone else in 2 different TLS handshake contexts. And then that gives you a bit more trust. Is that right?
I think that's probably mostly right. I do think there are some reasons to focus on this, on this assignment of roles. One of them is if the rule is that you just have to check with some independent party, and there are 10 well-known independent parties that people like to use,
right?
And then all the people on your relay choose one of them at random, then you've partitioned yourself into 10 buckets on that relay. So it helps a lot if everybody on the relay is using the same cache. So while it doesn't have to be physically on the relay, it does help to connect it.
Right. But that seems like it's like maybe it should be on your relay, but you could have alternate setups in which everyone talks to a different cache. And that doesn't have to be the same box as your relay.
Yes,
And you still get the
I
same
think it just
benefit.
helps if it's affiliated
Yes.
in a sort of one-to-one way.
Yeah, so no, I think the way that you structure this is quite good. I like the idea of using a double check sort of technique. I don't think the connect aspect of this is necessarily important here as much as the point that you just made about the relay being involved in caching the information. So concretely, what you're describing is you're going to talk directly to the authoritative source because that's necessary for correctness. The relay can't give you any assurances about correctness if you ask for its cache copy of it, but the relay does give you the ability to get some amount of consistency out of that. And so that's the structure that I would look for. I don't know that I like the connect stuff that you've put in this document. I particularly don't like the fact that you've added a requirement for connect UDP, which means that you've got not only connect UDP, but a requirement to use HTTP3 and a bunch of other things as well, which I think is somewhat more onerous than what we concretely need in order to obtain the properties that you're looking for. So I would prefer to maybe step back a little bit and look at the abstract thing and talk about those two things that I talked about before, and then talk about why you might choose to do things like connect tunnels and other things as optimizations or so on and so forth, as enhancements rather than being part of the core solution that you've described.
Sure. I would be interested to know whether you think, in general, for OHTTP, do you feel it's important that the gateway not learn the client IP addresses as a whole, the pool of client IP addresses?
The gateway. I don't think that in general that's a problem. I think it may become a problem depending on certain deployments and contexts. Yes, particularly when you consider the possibility that clients might also be connecting to the server that operates the gateway for other purposes outside of this particular usage. So it's something to think about, and we should probably document the consequences of taking the direct route as opposed to a proxied route. But concentrating on the core, which is we want correctness and consistency, and how we achieve that is probably where I would like to see this go first. Yep.
Okay, thank you.
Last question.
Eric with Google. A couple of comments. First, I really like this overall. I've been saying for a while that correctness and consistency is something we really need to solve, and you've taken a pretty good approach here, I think, and I want us to work on and fine tune this. Next comment, though, sort of the corresponding comment to what I said earlier in discovery and the config distribution. I see that one focusing more on being the payload, and the draft you have here currently does have a payload listed in it, and it's okay, we're just being redundant, and doesn't need that, so this should be pointing to that, and that should be pointing to this. Just strip the payload stuff out of this. Third comment, though, once we've removed the specific payload from this draft, this just becomes a generic draft for receiving a shared payload with proven correct and or validated correct and validated actually shared. And it's not even using Oblivious itself. So this stops feeling like an Oblivious specific thing other than the fact that we really need it. So at the cost of potentially slowing down a draft that I want yesterday, I almost suggest that we should maybe send this to a dispatch group to see if there's a better, more general place within IETF to have this. And if we can't find a better place, then yes, then we actually should adopt into this group then, because we do need it.
Sure. I do think that Ohai is the right home for this. I'd prefer not to try to go through more process steps there. On the format point, this draft does try to lay out a fully concrete instantiation of this thing. In order to do that, by my logic, we need a format that can convey the target, key config, and gateway URL as a unit, because they need to be cached atomically and rechecked atomically. And that format I will be talking about in mask, because it also embeds it also has the ability to represent mask information and dose servers. And, as we were just discussing, those are maybe not necessary for this, to use this draft, or to use this strategy, but appear to be beneficial for privacy when using this strategy. So
I think, Ben, I think we should wrap up. We're over time. Yeah, so I think we can take this on the list. Right, great. Thanks all for coming. I think the highlight was that we decided to do a last call for the main protocol draft, and there's some great new work lined up. So see you all next time.
Thanks for the time, everybody. Bye.